In this video, we shall learn how to compute paired or dependent t-test. See, the paired t-test, which is also referred as dependent t-test, is used to compare two mean values derived from same subjects at two different conditions. It means that when same types of individuals are being considered twice for a specific parameter, then we shall be having values regarding that parameter in one specific condition, and then we would be having values of the same parameter in a different condition. Like in this diagram, you see four different individuals of a snail species are shown, and suppose we are measuring their total weight. So we would be having weight of these four individuals in one condition, and then after certain period of time they are being observed for the same trait. So we can see the difference between the mean values obtained in two different conditions, and this particular test needs degree of freedom to reach on final inference, and that is calculated by the formula n minus 1, where n stands for number of pairs. Like in the present case, 4 pairs are there, so n will be equal to 4. Very simple method of calculation of this t value is there. This t value can be calculated by using the formula sum of d, where d stands for difference between the values of two different conditions. So sum of d divided by square root n, that is number of pairs, into sum of d square minus sum of d its square divided by n minus 1. And as I just told, degree of freedom will be n minus 1, and after that we shall need the t critical value at 5% level, or at the level at which we want actually to test our hypothesis. So this t critical means it is stable value. Let us see how the calculation will be done in a specific case. Here I have shown data regarding a particular trait. For example, the control conditions are there, in which 1, 2, 3, 4, 5, 6, 7 individuals have been observed for a particular feature. Suppose you have randomly selected 7 individuals from a population, and their hemoglobin content is measured in gram per deciliter of blood. So individual 1 that possesses 9 gram per 100 liter per 100 ml of blood, this much is hemoglobin content. Then the other one has this 10 value, the third one is having 7 gram per 100 ml of blood. So likewise you have measured 7 individuals from the randomly from a population, and then you have given them some kind of treatment, maybe that some vitamin supplement is given to these individuals, and then you have observed same feature, that is hemoglobin content, in these 7 individuals, and you find that there is change in these values of hemoglobin content. So you want to know whether the mean hemoglobin content of these 7 individuals differ significantly from the treatment one, or there is no difference. So our null hypothesis will be that there is no difference between the mean values in the two different conditions. So this will be our null hypothesis, and the alternate hypothesis will be the difference exists between the mean hemoglobin content of the 7 individuals observed in two different environmental conditions, or two different conditions. So the calculation method is given here. You have values of these 7 individuals, then you have treatment values, and then we have to observe the difference, that is 9 minus 12, so it will come minus 3. So from all these individual pairs, you see the difference will be obtained. So this has come -3. In the second case, it has come -2 because 10 minus 12 is -2. Then 7 minus 9, that has come -2. So this way, difference will be obtained in all these 7 cases, and sum of D will be obtained. This value has come -18. Then in the fourth column, you would be depicting D square. That is, individual D values will be squared. So -3, it will be squared, it will come 9. Then -2 is squared, it has come 4. Likewise, you will be squaring all these cases, and final sum of D square, that has come 52. So you have all these three important values which are actually needed. That is sum of D, sum of D square, and N, which is equal to 7. It means 7 individuals have been observed for this specific hemoglobin content trait. So N will be equal to 7, or 7 pairs have been considered. So this is the formula which I have shown you. T is equal to sum of D divided by square root N into sum of D square minus sum of D its square divided by N minus 1. So simply you have to put the values, that is, here it will be -18 divided by 7 into 52 minus -18 its square divided by 7 minus 1. So here in this formula, I have put all these values, and when you will calculate this, it will come -6.97. So T value has come 6.97. Now this symbol is not going to influence because this value could be in plus or minus. Now degree of freedom in this case will be 6, and at 6 degree of freedom, the critical value at 5% level, that is 2.447. So this you can observe uh, in this table. Here the two-tailed analysis is being done. So this is at 5% level, and degree of freedom is 6. So this value will be 2.447, because on the left side you can see the degree of freedom values are given, and here on the upper side, if you are doing two-tailed analysis, then at 5% level the value has come 2.447. So you have to actually compare with this value, and what we are observing, that the calculated value 6.97 is more than the table value. So we are actually rejecting the null hypothesis because probability will be less than 0.05. So we actually reject the null hypothesis, and we finally infer that there is significant difference between the mean values of the control and treatment. See, exactly the same thing is shown here in this slide, that if you are doing it by using computer program, then these are the values which have been put in the Excel sheet. And then if you go for this t-test paired two sample for means, if this analysis is being done, then you will be getting this table, this lower table, and by seeing this, all important characteristics could be known. See, the mean value of the first sample, that is control, is 8.7, and of the treatment is 11.285. So we want to know whether the difference exists between these two mean values. This is our purpose, and here variance values are also given for the two samples. Number of individuals analyzed are 7 in both conditions, and this will always be in the pair. And then the Pearson's correlation, this value is also given here. So if you are doing computer analysis, then this benefit is also there. And at 6 degree of freedom, the table value is 2.447. If you are doing two-tailed analysis, then your probability level will be 0.0004. So there is very very meager chance of happening of this event, it means you consider that there is significant difference between the two mean values.